Hi, folks. Thanks for tuning in. I'm sitting here in my living room today with my puppy Rosie and my kitty cat Tipsy, and they're going to be my teaching assistants as we work through using Trig applications in order to solve some problems. So hopefully by this point you have made yourself a nice little notes packet with all of your pages stapled together, and I'm going to start up at the top of a new page, and I'm going to title today's lesson Trig Applications. And I'm going to go ahead and I'm going to jump right into example one. In example one, let's just suppose that we have this tree that we're trying to find the height of. So you'll laugh because I'm a terrible artist. Well, here's my tree. I got to make good colors on my tree here. And I'm trying to find the height of the tree. In other words, I'm trying to find the distance from the top of the tree down to the ground. And I know that the distance from the base of this tree down to where I have a little measuring instrument over here is 62 feet. And I know that when I measure this angle using my little measuring instrument up to the top of the tree, I know that the measure of that angle is 57 degrees. And what I want to know, or what I want to find without having to climb all the way up there, is I want to find the height of the tree. So what's really cool, if you look at that red triangle without the tree, it's just the same old problem that we've been doing in using trig to find the length of a side. So I'm trying to find the length of this side in my right triangle. So I'm going to remember here, and I love putting these on a sticky sheet. I've got sine is equal to opposite over hypotenuse, or some old horse. Cosine is equal to adjacent over hypotenuse, or cot another horse. Tangent is equal to opposite over adjacent, or taking oats away. And again, if it were me, I would put those on a sticky note, and then I'd have them to move from page to page. So I need to decide which trig ratio I want to use. So I'm going to go label in my picture my hypotenuse, my opposite, and my adjacent. So here's my hypotenuse. Opposite or across from the 57. If I look opposite or across from the 57, that's my x. So x is my opposite, which means 62 is my adjacent. So I don't know the hypotenuse. I know the opposite and I know the adjacent. So I want to use the trig ratio that deals with opposite and adjacent, making this a tangent problem. So tangent is equal to opposite over adjacent. Tangent of 57 degrees is equal to opposite, which is x, over adjacent, which is 62. And at this point, I'm going to pause because I need to go get my calculator out. If you don't have your calculator handy, why don't you hit pause also so that you can go dig out your calculator, and then we'll come back and we'll do this. Beautiful. So I got my calculator out, and I hope you did too. So into my calculator now, I'm going to go find the tangent of 57 degrees. I'm always going to check to make sure I'm working in degrees, which I am. So tangent of 57. And remember, I'm going to put on my paper just the first four decimal places, whatever those are. 1.5398. And I'm not going to worry about rounding here. If I wanted to, I could put the whole decimal display down, but I have to put it a minimum 4 decimal places. And now I'm going to go ahead and cross multiply. So x going in that direction is equal to 62 times my 1.5398 number. And I'm going to go ahead and I'm going to copy that down to the next row. So I'm going to go highlight that number and cut and paste it because I need to multiply that whole entire number times the 62. And I think for the sake of just being consistent, we are going to round in this video. We're going to round these to the nearest integer. So let's do 95 here because 0.47, remember 47 is closer to 0 than it is to 100, so we're not going to round up. So we'll say 95 feet. So that's a pretty tall tree. Definitely not one that I would want to climb up to measure, which is, so I'm glad that we can find its height without having to climb all that way. So that's one way in which we might use our knowledge about trigonometry to solve a problem. I'm going to jump down now, and this one I'm going to call example 2. And this one's a little bit different. This time we have a cliff, and this cliff we know is 75 feet tall. And my cliff is not a very good cliff, but you can use your imagination just a little bit. And somewhere down here there's some water. And in this water we have a boat. See, if we had notes in class, we wouldn't get to do all these drawings. So there's my little sailboat. And from this boat, we're going to take and we're going to measure up to the top of the cliff. And we find that when we measure up to the top of the cliff, we find that that angle is 18 degrees. And in this problem, we want to figure out, or we want to determine, how many feet that boat is away from crashing into our cliff. So again, I've got this kind of rough sketch here, but what I'm really going to focus on is I'm going to look at that triangle. I'm going to look at that right triangle. And this cliff is a vertical cliff, straight up and down. So we know that that angle's a right angle. So again, I'm going to go ahead and I'm going to label my triangle hypotenuse, opposite, which makes this guy adjacent. So we don't need the hypotenuse. We're dealing once again with opposite and adjacent. So this question, like the first question, is a tangent question. So the tangent of that 18 degrees is equal to my opposite side, which is 75, over my adjacent side, which is x. And again, I'm going to head into my calculator, and in my calculator I want to find the tangent of 18 degrees. And again, regardless of what those first, I'm going to put the first 4 decimals down on my paper. So 0.3249 equals 75 over x. And now I'm all set to go ahead and make that a proportion and cross multiply. So I've got my 0.3249 times x going in one direction is equal to 1 times 75, or 75 going in the other direction. So now I need to divide both sides by my 0.3249. So x is going to be equal to the 75 divided by the 0.3249. So I'm going to go ahead and put 75 in the numerator, and then in the denominator I want to go cut and copy and paste. So again, I'm using that entire decimal when I plug this into the calculator. And again, when I round this to the nearest foot, I've got about 231 feet. So I know that my boat is about 231 feet now away from crashing into that cliff. Nice. All right, Rosie, my puppy, says that was fun. Let's try another one. I'm going to go up to the top of the next page, but you can really write this wherever you want to. If you still have room on that page, feel free to write that one right on the same page that you were using. So I bet you couldn't have guessed. I'm going to call this one example 3. And example 3 is kind of cool, kind of different. What I've got in example 3 is I've got a ladder leaning against a wall. So here's my wall. Oh, and I'm such a bad artiste. Here's my ladder. So this ladder is leaning against a wall. And I know that in order to do some painting, I need to reach up 20 feet up the wall. And I know that in order to be safe, I need to put the ladder at an angle of 75 degrees away from the wall, or lean the ladder at that angle of 75 degrees. Our wall, remember, is always going to make a right angle with our floor. And I want to know when I go to Home Depot how long I need that ladder to be. So again, I'm looking at this right triangle and I'm going to use some trig in order to figure this out. I don't have mine on a post-it, so I'm going to write them down. So, ka, toa. And I'm going to go figure out which one I need. So x is my hypotenuse, 20 is my opposite, which means this piece along the floor here is the adjacent. So I don't need adjacent. This question deals with opposite and hypotenuse. And the trig ratio that deals with opposite and hypotenuse is sine. So this question is a sine question. So sine of 75 degrees is equal to the opposite, which is 20, over the hypotenuse, which in my picture is x. I'm going to go back to my calculator. I'm going to grab the sine of 75 degrees, 0.9659 is equal to 20 over x. So 0.9659 times x, when I cross multiply going in one direction, is equal to 1 times 20, or 20 going in the other direction. So I'm going to go ahead and divide by the 0.9659. And I'm going to go enter this fraction into my calculator, keeping in mind that when I do, I need to make the denominator that whole 0.96 number. So I'm going to have to cut and copy and paste. So let me go copy that number. And again, the whole thing goes in there. So I would say that to the nearest integer, I need my ladder to be 21 feet long. I really like the applications because I think you can see how you can use this trig, or how you might envision using this trig out there in the real world. All right, we have, folks, one more for today. So this one I'm going to call example 4. And in this one, I'm going to build a ramp for a wheelchair. I know that I need this wheelchair to rise up, or this ramp to rise up 2 feet from the ground. And I know that in order for the person to be able to wheel themselves up the ramp, I have to incline in an angle of 2 degrees. And I want to know in this question how long I'm going to make my ramp. So this is what I want to find here, the length of my ramp. So if you have a sticky note, you can move your sticky note around, but I'm going to write them down again. Some old horse caught another horse, taking oats away. So there's my right angle right there, which makes my hypotenuse x. The side that's opposite from the 2-degree angle is the 2, which makes the remaining side the adjacent side. So we don't want adjacent, we want opposite in hypotenuse. So this question, like the first one on this page, is going to be a sine question. So sine of 2 degrees is equal to my opposite side, which is 2, over my hypotenuse, which is x. So I'm going to go to the calculator and type in sine of 2, 0.0348 is equal to 2 over x. I'm going to turn this into a proportion. So 0.0348 times x when I cross multiply going in one direction is equal to 2 when I cross multiply going in the other direction. Now in order to solve for x, I want to divide by the 0.0348 number. So again, when I go to plug this into my calculator, I need to use not just the 4 digits, but I need to put the whole, all of the entire decimal display into my calculator. So I need this ramp to be about 57 feet long in order to incline those 2 degrees. All right, folks, thank you for sticking with me today. You have an assignment in Castle Learning so that you can go and practice these skills. When you go to Castle Learning, it's assignment number 4, and it's called Trig Applications with Finding Sides. And as always, if you have questions, please feel free to join me Mondays, Wednesdays, and Fridays from 10 to 11 in Teams. You can always email me and we can set up a time to Zoom if that's easier. But if you have questions, I'm here for you. And I know that Miss Andre is too. Please don't be afraid to reach out and ask one of us. We would really, really love to hear from you or see you or get together and work on some of this geometry together. Miss you guys like crazy. Me, my teaching assistants, Rosie and Tipsy, we're signing off.